So as you know, I sent you email that we are very fortunate that we have the guest speaker today here. So please put completely attention for that lecture. There will be questions on the midterm, on the final exam. So I was checking if you are putting the attention. And you will learn a lot, and also it's quite entertainment way explain you everything about water. So you will love that subject. And so let's do now warm welcoming to our guest speaker, Dr. Will Cooper. Okay.
Thanks, Zuzana. So we're starting out on a bad note. I went to Java City, but there were too many people there, and I didn't have time to stop at Phoenix Grill. So if I fall asleep during the lecture, it's because I didn't have my 12th cup of coffee this morning. Okay, so I'm the water boy on campus. I direct the Urban Water Research Center in the School of Engineering, but it's actually a university-wide center. We have people from social ecology, the medical school, biology, chemistry, computer science, and everything within the Urban Water Research Center. So today's talk is going to be about water and what I title the Looming World Crisis, Climate Change and Water. But involved and embedded in this is public health, and we'll see that theme through the talk today. I think it can be said that, in fact, water lies at the intersection of some of the most major issues that are going to face you, the professionals of the 21st century. And I do believe that. I won't see it. I'll be gone. But you guys are going to have to deal with water because it's intricately related to public health. So when I talk about the water sector, I don't want to go into a lot of detail, but basically water is more than just H2O. We have industrial and ultra pure water for making silicone chips for your manufacturing your cell phones and stuff, for example. Drinking water, of course, is what we're mainly interested in, but we're also interested in domestic wastewater treatment. So we're interested in sanitation and in healthy water. Water reuse is an area that I've been involved in since the late 70s, actually. And we have the world's largest indirect potable reuse facility plant right up here in Fountain Valley, the Orange County Water District's groundwater replenishment system. And that's where we're doing toilet to tap. We're taking wastewater and we're treating it to a level beyond drinking water quality, and then unfortunately right now we re-inject that in groundwater, and then it's withdrawn as a groundwater source. The biggest bank for water in Southern California is, or reservoir, is underground. It's groundwater, and we're hoping to go from re-injecting that water back into the ground, contaminating the water. We're actually hoping in the next 5 or 10 years to go to direct potable reuse. That is, we'll have at one end coming in wastewater and the other end going out drinking water, and it will never actually go into the groundwater. It'll go right into your drinking water tap. That sounds horrible, but if you ever have a chance to go up and look at the Orange County Water District, it is an amazing industrial facility for treating water. It is the largest in the world, and it is, in fact, one of the best. I would suggest that it is the best in the world. Okay, we're not residuals. Whenever you're treating water or wastewater, you always come up with some residuals, and that's something that's of interest. Reject streams, when you use reverse osmosis, not all the water goes through the membrane, and so we have to deal with these things. Produced water is associated with energy production. Contaminated groundwater is legacy in the most cases, where we didn't realize what we were doing when we dumped chemicals out on the ground that got in contaminated groundwater. And there's many more areas. So you can see that when I think of the water, of water, the whole idea of water, the water sector, is enormous. When I think of water availability and water sustainability in the United States and in the world, I think in terms of water reuse, because I feel that this is, in fact, the central theme to sustainability. And we'll talk about that on and off throughout the lecture today. Interestingly enough, the climate change is changing all of the rules of the game for water resources, and we'll see a little bit about that at the end of the lecture. So what we're doing now is we're trying to look at water and wastewater treatment through what I call the CO2 lens. you know that carbon dioxide is the major climate warming chemical. And carbon dioxide comes from burning fossil fuels. 20% of the energy in the state of California actually goes to transporting water, treating drinking water, treating wastewater, treating imported water, and then actually disposing of the water. I'm not going to go into these in any detail, but some of the things that we think about in my business are economic models, biosolids, agricultural practices are a huge area. And my own research directly deals with public health because I'm looking at pharmaceuticals in water. So I'm a point source of 4 pharmaceuticals. I take 2 for glaucoma, and I take 2 for my blood pressure and cholesterol. So, and when I take those medicines, I only metabolize or even use probably less than 50% of them. So they're then excreted. So I know for a fact that I'm a point source of 4 pharmaceuticals. And those pharmaceuticals and other endocrine disrupting chemicals are a major area of concern in water treatment. And so that's what we're doing a lot of work with now. Infrastructure, it's estimated probably on the higher side is closer to being right. When we talk about water in the United States, I'm talking right now just about the United States, we have these huge metropolitan areas. So that means that we have to be able to collect the wastewater, and we have to be able to distribute high quality drinking water. And we do that through pipes underground. That's what we call the infrastructure. And it's being sorely abused and in fact forgotten. And it's now estimated that probably close to $400 billion will be needed in the next 15 or 20 years to upgrade our infrastructure so that we can minimize contamination of the environment. We can maximize the water quality that we get at our tap. And so at any rate, that's another area. So what I want to do is I want to start by looking at the international scene on water. Many of you are not necessarily from the United States. You have roots in other countries. Well, we all have roots in other countries unless you're Native American. And then it can still be argued you have roots in other countries. But we're going to take a look at the international scene. Then we're going to look at Southern California. And then we're going to talk a little bit about climate change and how that's going to impact you, water, and the world.
There is no greater issue confronting the world than the water scarcity and quality crisis.
How many people have had water like that for your drinking water source? Probably very few. There may be somebody. So I would say that there is a definite relationship between water and public health. In fact, I would argue, because I'm a bit prejudiced, that one of the most important areas in public health is water. Water availability, water quality, and sanitation. But as you see, I even have 2 little smiley faces because I'm obviously the water boy, so I think that's the most important thing. Interestingly enough, I think that we are not living sustainably. The biggest enemy to water, water security, and water sustainability is population growth. We're at 7 billion people on the face of this earth, and it's projected that by 2050, we're going to be up at 9 billion people. Okay? One of the things that you and your generation is going to have to deal with is population growth. There's only one country in the world, and that's China, that's actually starting to grapple with that head on, where they're minimizing or saying that you can only have 1 child per family, okay? Nobody else has had the guts to actually start looking at population growth. That is singly the biggest problem that the planet faces, is the population expansion of the most intelligent, quote unquote, being on the face of the earth. But by far the biggest unknown in water is climate change, and how climate change is going to affect the rainfall and snow precipitation around the world. We're predicted here in Southern California to get drier, not wetter. And I'll show you some data over the last 10 or 12 years that will confirm that prediction. But with climate change, what we used to do, how we used to project water resources, is that we would look through the historical record, okay? And then we would project into the future, and generally it was a straight line. But that's not the way with climate change that we can predict the future. All of the rules of the game are being changed because climate change, one, is a planetary issue. It's not just a US or a China or an India or an African problem. It's worldwide, and it's will affect water in every country in the world. So of the 7 billion people on our planet, nearly 1 billion of those people do not have access to potable drinking water. 1 in 7. Okay? But even maybe more startling is that 2.5 billion people out of 7 don't have access to adequate sanitation. Okay? And if we don't have adequate sanitation, how in the world can we have clean water supplies for the population? This is the estimates of the population growth. So back in the 1800, there were about 1 billion people on the earth. And you can say these are the United Nations. This is the high projection. This is 2100 down here. This is the medium projection. And this is the low projection. Well, the low projection you might just not even put on the map because there's no way in heck we're already above that. They said it, well, we're not quite at 8 billion and we're not quite at 2040. But there's almost no way that this is going to be realized. I would like to think that this medium one would be realized, which means there's only going to be 10 billion people in 2100. I won't last that long. You guys might if you're lucky. But look at this. The high is nearly 16 billion people on the face of this earth. It just can't happen. The earth is not designed to have 16 billion people on it. It can't sustain that many people. So you know what's going to start to happen in here. There's going to be wars. There's going to be floods. There's going to be all sorts of disasters that happen because we just can't sustain that number of people on this planet Earth. In fact, I would argue, and there's a number of people that have proposed a very controversial system, that we need to get back down to 5 billion people or lower in order to appreciate, in order to be sustainable on the planet Earth. Right now, we are taking more resources from the planet than we're giving back to the planet. So this is a real critical issue. People say, you're full of, I won't say it because we're on tape. But it is a critical issue. Water is going to become one of the issues that is going to face you every day as you go further. And if you go into some of these developing countries, I've done some work in Kenya and in Tanzania, it's there already. And what we're trying to do now, and I was just talking to your professor, Zuzana, here, that Engineers Without Borders here on campus has actually invited her to come and speak to them about public health. We have a group which is an undergraduate and a graduate group of students that do Engineers Without Borders. They've done a project in Kenya. They're going to be going to Costa Rica to do a project. And if you're interested in civic engagement and outreach, I would suggest that you try to get in touch with the Engineers Without Borders, and I can put you in touch with that group if you want. In order to feed the increased population, the food production is going to have to increase by 70%. Interestingly enough, I teach a freshman course in water. It's a FIP, freshman or a first year integrative program in water. And we went through some of the footprints. And the United States exports 32 million metric tons of wheat a year. Okay? If you think in terms of water equivalents, how much water we're exporting, it turns out that if you went up to the Orange County Water District's water plant, and if you ran that for 120 days, that's the equivalent of the water, making 70 million gallons of water a day, times 120 days, that's the amount of water that we export. So when we're talking about increasing the food production by 70%, that's almost double what it is now, just in order to feed this growing population, there are going to be some major issues that are going to face you as the professionals in public health. So our agriculture depends on cheap oil and plentiful water supply. With climate change, we don't know what the patterns of precipitation are going to be in the Great Plains where they grow most of the wheat. But we do know one thing. The days of cheap oil are gone. Oil, gasoline at the pump is going to get more and more expensive because we're running out of oil. So there's some interesting things that you'll hear. A nexus is where we cross things. So there's not only a water-oil nexus, there's going to be very rapidly a food/agriculture water-oil nexus. And you will see that in your lifetime, no doubt about it. So can you imagine that?
Worldwide, a child dies every 15 seconds from diarrhea. These quiet, preventable deaths hardly receive any attention.
I want to play that again. This is one of the most, in my mind, one of the most impactful sessions within a 20-minute video called Running Dry.
Worldwide, a child dies every 15 seconds from diarrhea.
Those are all dead bodies in there.
These quiet, preventable deaths hardly receive any attention.
Can you imagine that? As a mother or a father having to put your baby into the back of that truck and cart it away? 5,760 children die every day as a result of waterborne diseases. That means that every year, with the population of only 7 billion, we have 2.1 million children dying every day, every year, and they're 100% preventable. All you would need is just a little chlorine to kill the cholera and other pathogens that are found in untreated water. So the question that I ask myself, if we've got 7 billion people on the face of this earth today, what on earth is going to happen in 2050 when we have 9 billion people? You're going to face that. This question is going to rear its ugly head over and over and over in your lifetime. Whoops. I got to do a clicker here.
40% of Africa's population is expected to suffer serious illnesses over the next decade. Frequently fatal because of water quality problems. Around 700 million Chinese, half of the country's population, consume drinking water contaminated with animal and human waste. China's effort to become an economic and industrial power has been at the expense of the environment.
There's somebody who wants to get in over there. We got to tell them that class starts at 9:30. In China, this is a lake that serves over 20 million people drinking water. It's Lake Tai, just a little bit west of Shanghai. And as a result of dumping raw sewage and untreated waste into this lake, there are harmful algal blooms. This happens to be just a green algae, but it could be microcystis, for example. And microcystin is an algae that actually has a toxin that will make you sick and could even kill you. The interesting thing is about water. China right today has 21% of the world's population, yet it only has 7% of the world's fresh water. India has 17% of the world's population and only 4% of the world's fresh water. Okay, and of that 4%, 2/3 of it is already contaminated to beyond human consumption. So there are, in the United States, on the other hand, is very fortunate. We only have about 5% of the world's population, but we have 15% of the world's fresh water. And if you don't think that there's going to be wars fought over water in the 21st century, you're wrong. There are already starting to be agitations between Azerbaijan and China on the Western China area. So we're going to see that wars will be fought over water in the 21st century. They won't be fought in oil anymore because oil will be gone. Okay? I think it is an imperative that the developed countries like the United States have a responsibility to help solve this global crisis. Many of the developing countries don't have the capital and the people power to solve these problems. I liken this to the Iraq War. And during the Iraq War, the United States was spending $2 billion a week fighting this war. And what I said is 2 Iraq months, that would be 8 times 2, $16 billion, could have solved 50% of the world's water problems. And I think and yet, do you ever hear political people talking about clean water, clean drinking water? No. We've just, during this last election, other than Gore when he was running with Clinton, started to think about climate change. And climate change is a shameful thing in our political system in the United States here because it's become a political issue, not a scientific issue. And that's really wrong. So this is a fellow from Palestine.
The water problem, if we succeed in solving, refugees will follow, borders will follow, security will follow.
Oops. So you can see that the Middle East is a hot spot for many, many reasons, not the least of which, of course, is water. But water then leads to public health. So, and look at Haiti. They had that horrible earthquake in Haiti. We had an emergency medical team from UCI go to Haiti, and one of the fellows that was doing surgery had no water to do surgery with. He was using this spray bottles and stuff just for disinfectants. And you can't expect to have to be able to do public health down there without water. I mean, it's just impossible. Let's turn our focus just a little bit to the regulatory environment in the United States and what led us to the fact that you can go around the United States and in 99.99% of the time you can open up the tap water and get clean water. Well, in the 1970s, there were about 200 million people living in the United States. Now we have about 310 million people. So as of April 2009, there were 306 million, but I think I think we're closer to about 310 million. So when all of the legislation for clean water and clean air were passed, we had 2/3 of the population that we have today. And yet none of those regulations have been updated to any great extent. What were the two catalyzing moments? Rachel Carson's book entitled Silent Spring woke up the public to the fact that we are killing ourselves by contaminating the environment. Okay? I did a TEDx, I have a picture or two from that later, but I did a TEDx about sustainability. We had a TEDx UCI out here. And I feel very strongly that in general the population is not connected with the environment. So, just to give you an idea, we're going to do an exercise here, okay? So everybody take a deep breath. Take another one. One of those breaths came from the land, the plants around our green trees. One of those breaths came from the ocean. Yet you can't see it in the ocean. It's these little plankton, these little algae that are doing primary productivity in the world's oceans, give us 50% of our oxygens that we need in order to maintain our livelihood. So the idea of doing that little exercise is to realize that we can no longer accept rivers burning. This was in Cleveland, Ohio in the 60s. The Cuyahoga River was so contaminated that it caught on fire 2 or 3 times. And when this was put on TV, and TV was, in 69 was, I guess maybe color TV was there, it was mostly black and white. That dates me. So you can see that people said, oh my God, we are doing such a horrible thing to our environment. How can we possibly hope to live? When they did a survey of the fish in the Cuyahoga River that year, they found 11 fish. Not 11 species, they found 11 fish. And after they then started to clean up their act, then they've now got thousands of fish in 22 different species, plus or minus, I don't remember the exact numbers. But it's amazing what you can do when you put your mind to it. So if you go back to that green lake that I showed you in China, that's not a problem that we haven't seen here in the United States. The good news about the United States is we've made every mistake possible. The thing I wish that developing countries could do, and we should help them out, is to try to avoid them making the same mistakes that we did. And this is certainly an example of a horrible mistake. In 1969, I was actually playing soccer. Well, actually, I was just about ready to graduate sometime around 69. But I was actually playing soccer in Cleveland. I was a collegiate soccer player, and we used to play soccer. I didn't ever see this fire on the fire on the Cuyahoga, but we were maybe playing soccer up there. That's why I died that day. All that black smoke. Okay. I can't believe, if we look at this picture, I can't, so I'm really critical of the political process in the United States. Can you believe that there were people running for president that said EPA should be disbanded? Without EPA, without those watchdogs looking at our environment, what on earth's going to happen to our grandchildren? Do you want your grandchildren, do you want your children to see this? Yes.
Who was the president at the time?
Huh?
Who was the president at the time?
Oh, that's a great question. It was President Richard Nixon.
Screw him.
Well, interestingly enough, we finally got rid of him after Watergate. But actually, interestingly enough, the Clean Water Act, I like that attitude, by the way. He actually did some good things. He actually started the EPA, but then when the Clean Water Act, which cleaned up all of our waterways, went on his desk, he actually vetoed it. But that was when we could actually get something done in the Congress of the United States. And on the next day, or the October 18th in 1972, both the House and the Senate overrode his veto, and we had the Clean Water Act. So what I wanted to tell some of these presidential people that were wanting to ban or get rid of EPA is, don't you really have any feeling for your grandkids? Are you so greedy? Greed is the #1 problem we face in the United States, that you don't even care about your family and your grandchildren? This is why, believe it or not, this is why you guys are in public health. It's because you really care about environmental health and public health. As an environmental engineer at the 30,000 foot level, we have 2 mandates: to protect public health and to protect the ecosystem or environmental health. So believe it or not, public health and environmental engineering are linked. So that some of the headlines at home, we need to remember that we can bring this right back down to home. In 2007, Lake Mead gives us 30% of our water here in Southern California. It was predicted to dry by 2021. We've had a couple of wet winters, so it probably won't, but you never know. Danger on the Delta. So an interesting statistic is that from Santa Barbara to Tijuana, Mexico, to the Mexican border, we have the Metropolitan Water District of Southern California that basically imports and provides most of the drinking water to us in Southern California. The economic engine that drives that Southern California is $880 billion a year, which ranks California, Southern California, somewhere in the top 20 countries in the world economically. Yet, we import 60% of the water that's needed to fuel that engine. So $880 billion a year. You can imagine how many taxes that pays. Yet, we get 30% of our water from the from the Colorado River, and 30% from the San Francisco Bay Delta area. What's the probability of losing one or both of those supplies? 100%. Within the 21st century, I predict, and whenever I predict, I'm wrong, but I'm going to predict, because I'll never know, I won't be here, that when we get water from the Colorado, we pipe it up over the San Bernardinos, among other mountains. What runs underneath the San Bernardino Mountains? The San Andreas Fault. Last year, we had 400 little earthquakes. It's only a matter of time before we have a good jolt out there and we lose that water supply. It would probably take maybe less than a year to get this water supply back, but we'd be without 30% of our water for a year in Southern California. On the Delta, Stephen Flynn has written a book about the edge of disaster. I had the privilege of listening to him talk about this book, and what a phenomenal speaker he is. But we get 30% of our water from the Bay Delta area. What's the likelihood of a magnitude 7 earthquake in the Bay Delta area in the 21st century? About 100%. Now, if we lose that 30% of the water, it's going to take them 3 to 5 years to rebuild that distribution system. So I'm thinking that we are in a very dire strait down here in Southern California. And the biggest problem with the water, we call if you keep forgetting, I can't use some words that I would normally use. The older people in the water field, we call them water buffaloes. You know, in Orange County alone, we have 28 different water districts, each one of them with a publicly elected board that determines what's going on. And it's amazing how we get anything done here in Southern California with that kind of a system. So at any rate, the point is that in order to maintain our economic viability in Southern California, we have to have a sustainable source of water, and that's in fact why I'm arguing that we need to go to pipe-to-pipe water reuse. My big area really intersects what you do. My largest research program right now is actually looking at pharmaceuticals in water and in wastewater. And so we're doing a lot of our research there. In Laguna Beach, in 2008, and then there was a more recent one, they actually had a sewage leak that snarled not only cars and stuff on the Pacific Coast Highway, it dumped raw sewage into the ocean. And it's not really much fun to go swimming in raw sewage. So on the other hand, look at the drought. In the spring of 2012, so that's this year, I have to remind myself because I can't remember what year we're in. In the spring of 2012, the Mississippi River, which comes down here, had the highest recorded flows in history. 3 months later, we're in one of the worst droughts, other than the Dust Bowl of 1935, that we've ever experienced. These may be indications of climate change. I won't try to jade you into thinking that they are. But one of the things that we see with climate change and global warming is that the extremes will be higher and possibly more frequent. So we might expect more flooding. The watershed of the Mississippi is something that looks like this. I mean, it's a third of the United States. And by the time the water gets to New Orleans down here, it's been used 20 to 50 times, depending on the flow. Not necessarily for consumptive use, but it's been reused that many times. So here we've got, in the spring, the major flooding in the Mississippi. And by this summer, this was July 31st, we have major droughts. And what is this area of the country? That's the breadbasket of our production of wheat. This is where we produce 32 million metric tons of wheat every year. Much of that is used, actually that's what we export. That's not even what we use. That's just what we export to other countries. Some of it in terms of aid and some of it in terms of revenue. So I've already told you this, but I really want to emphasize, in Southern California, 60% of the water, so 2 out of 3 glasses that you drink out of the tap, or 2 out of 3 of the flushes that you flush down the toilet, come from somewhere outside Southern California. We are dependent on California from the San Francisco Bay Delta area and the Colorado River. But I think I'm going to convince you that the Colorado River is running dry. What are we going to do about that? That's going to be an interesting question. So the Colorado River starts up here in Colorado, and then here's a little bit of Idaho. There's Nevada, Utah, Oklahoma, Texas, New Mexico, Arizona. The upper Colorado, which we're not going to talk about today, is fed by Lake Powell. Okay, the lower part so I've just told you that. The lower part of the Colorado, which is fed by Lake Mead, which is just outside Las Vegas, Nevada, feeds water to Nevada, Colorado, California, Arizona, and New Mexico. So water law is a very complex issue. And in the United States, we have Eastern water law and Western water law. Western water law is first in time, first in right. So that means that if your grandfather had come down here, well, let's just put him in Southern California, the poor buggers by the Salton Sea. But say he's down here and does agriculture, and he withdraws 1 million gallons a day of water for beneficial use, growing crops or something like that, in 1890, your family, he has established water rights, and your family is still you can still demand 1 million gallons of water every day or every year for your crops there. So the interesting thing is the Colorado River is under Western water law. So it's prior appropriation. And what that means is that people have to establish when they first started using water, and then it's allocated between the various states. And what happened is California lucked out because in the 30s we spent, I think we paid for 2/3 of the Hoover Dam. So we have a lot of water rights on the Colorado. We basically purchased them that way. But the thing is, when we distributed the water from the Colorado to these 5 states, it happened to be that we were using a time in history when there was relatively full Colorado River. It was running very high. And now, because the amount of water that's going down, it's oversubscribed. In other words, if everybody here said, okay, this year I'm taking all of my allocated water, we would completely dry up the Colorado River. So once again, we've effectively screwed Mexico because the Colorado River used to drain out into Mexico and into the down here in the Sea of Cortez. It hardly ever makes the Sea of Cortez anymore. So aside from some international issues, we're going to have some issues in these states as the Colorado River starts to dry out more. So Lake Mead is the largest reservoir in the United States. It's located in the Colorado, about 30 miles from Las Vegas, and formed by the Hoover Dams. Anybody here seen the Hoover Dam in Lake Mead? It's pretty impressive. As an engineering thing, it's unbelievable, isn't it? When it's full, and it hasn't been full for a long time, it extends upriver 112 miles or 180 kilometers, and it holds approximately, well, this is easier, 35 cubic kilometers. So that means it's a kilometer by a kilometer by a kilometer. That's a cubic kilometer. Or if you're a football or soccer player, it's 10 soccer fields this way, 10 soccer fields that way, and 10 soccer fields that way. That's a cubic kilometer of water. It's a lot of water. That's when it's full. Lake Mead has got a serious problem with ring around the collar. In 2007, it was 118 feet below maximum. It was at 46% capacity. I got this picture and this information from Ken Dewey. I'm not exactly sure where he is, but I got this some years ago. If we look here in 2009, it had come back up, but it was still 100 feet of ring around the collar here. My friend Pat Mulroy, who runs the Southern Nevada Water Authority, was so scared that these lake levels would continue to decrease that she spent $1 billion digging through these mountains underneath so she could get more water to feed Las Vegas. Because at the rate it was going in 2007, she would not have any water in 2012 or so. Luckily, we got a little bit of rain, and it helped. So the maximum level of Lake Mead is 1,229 feet above sea level. In 1998, when it became fully charged, it was at 216 feet above sea level. 2010, it was at 1089. So we were really hurting in 2010. And May 15th, it was back up to 1095. I'll show you some pictures here in a minute. The real question that people, again, are asking is this the norm? Is this 12-year drought normal, or is it an anomaly of weather? If you believe the global climate models, it's probably going to be the norm, and it's going to get worse. So, again, I don't think we have to look very far to think about the fact that water is going to be a critical issue in the 21st century. This is what happened earlier this year. From the maximum elevation was 1134, okay, and the minimum on May 28th. But look at what happened. So about here, we have a very smart governor. He says, we're out of the drought. Don't worry, you can use water. Oh, that's really pretty stupid. Because now look at what happened. It just continued to go down and down and down. If we look at, so that I got that when I was giving a lecture in May. Okay, so now it's November, and you can see that yes, in May it was down to about 1118, but you see it continued to go down, and then we had some recurrence. This recurrence is not due to rain. It's due to the release of water from Lake Powell on the upper part of the Colorado River. But then it started to go down and back up, and it's down. And today it's at about 1115, okay? So if you look at this is when the Hoover Dam was built in 1937. And as Lake Mead started to fill up, it got up to 1220. And then it went down. You can see there's some pretty shaky times. There was a drought back here in the early 50s. Went back up, another drought. And then slowly but surely up till 1980 something or other, it reached almost 1,200, I guess that's 1,229 feet. But look at what's happened. It kind of diddled around here. But since the late 1990s, it's had a steady drop. Now, I don't know, this is an increase, but right now we're at 1115. So if this is 1100 and this is 1110, we're right here. Drought is defined as 1125, so we're already 10 feet below drought. Now 10 feet, when you think about it, doesn't seem like very much. It's not even this much. But when you think about the whole of Lake Mead, which can be, when it's full, 112 miles, that's a lot of water. We're losing water. So what we're seeing here is what we think may be the norm. In other words, as the climate tends to warm and the climate change starts to take hold, we're going to see less and less and less water. At 1075, we're at a critical shortage. I think a little bit below 1075, not only are we going to start to worry about our water supply, we're going to lose 30% of our electricity supply. 30% of the electricity that's used in Southern California comes from the Hoover Dam. So not only are we thinking about water, we're thinking about electrical energy as well. I'm not going to go into this. This is just a little bit of detail. Well, actually, you can see where we are now. This was this year. It's now down at 11:15, so it's right about here. Oh, we're out here in November. It's right here. So you can see that a couple of years ago we were really hurting. The reason I'm talking about this is 30% of our water supply is dependent on Lake Mead. And if Lake Mead dries up or goes to a certain level, we're going to lose all of our water supply, 30% of it at least. Okay, so let's talk a little bit about sea level and sea level rise, because I think, to me, this is one of the biggest issues that we have to deal with, certainly here on the coast and certainly in the long run as far as water is concerned. How long have we got? To 1040?
10:45.
Okay. So I already mentioned that when we were doing water resources planning in the past, we used to look at the past and project the future. But today we can't do that because things are starting to go up. They don't go up linearly or linear like this. It's actually more of a hockey puck stuff. And when I heard Michael Mann, I think it's Michael Mann, of Penn State give a talk up at the Aquarium of the Pacific last year about this hockey puck stuff. We are no longer capable of predicting water resources with any certainty as a result of climate change. And that's why I say that the biggest enemy of water is overpopulation. The biggest unknown in water in the future is going to be population control. So, if the sea level goes up 1 meter, we lose approximately 20 nations. There's already island nations that are evacuating because they've lost their source of potable drinking water. They have no source of potable drinking water. And I'm not sure exactly if it's 20 nations. That's just an estimate that I made, but I can think of several that will be gone. I won't go into this bromide issue. This actually is very relevant to public health because as seawater intrudes our groundwater reserves, which we use for drinking water, it brings with it two ions, bromide and iodide. Iodide, of course, you know, is critical because thyroxine in your thyroid is what helps your thyroid monitor operate functionally. But too much of iodide or too much bromide, when you're disinfecting the water for drinking purposes, ends up producing byproducts, organic byproducts and some inorganic byproducts that are extremely toxic. Okay. So let's look at some figures. This is sea level rise. Why do we care about sea level rise in California? One, we've got 1,100 miles of seacoast, okay? If you're living down in Laguna Beach and you're on Lido Island or Balboa Island, a meter of sea level rise is going to put you permanently underwater, okay? This is the rise, the change. Delta means change in the mean sea level in millimeters. So we're talking about millimeters. It's not a lot. But since 1960 to this data was about 2003. I need to see if I can find a more up-to-date. This was provided to me by a woman over in, I want to say Alexandra, but it's not Alexandra. Over Isabella Villiconia over in Earth System Science. We have two of the top people in sea level rise in the world as faculty in Earth System Science. And they're doing a lot of remote sensing. They're doing a lot of work with Greenland and Antarctica. And we'll see how that comes in a minute. So this is the sea level rise. So you can actually draw a regression point through that and come up with the fact that from 1961 to 2003, there was about 0.5 millimeters per year of sea level rise. Okay? If, on the other hand, you do that and you look at 1994 to 2003, the rate has increased by almost twofold to 0.9 millimeters per year. And that's what I mean by this hockey puck. It's not going up linearly, but it's starting to go up like this. And the question is, how far is this bend going to bend in the next 20 or 30 years? Is it going to start to go up asymptotically very high, or what's going to happen? That's where climate change and water resources intersect. So what she tries to do is she actually tries to look at the 20th century. We had an average over the 20th century of 1.8 millimeters per year of sea level rise. And she says, okay, the change in the sea level, the total sea level rise that we can account for is 1.4 out of the 1.8. So a lot of it has to do just with the warming of the ocean. As you warm water up, it expands. And so 0.4 millimeters per year is nothing more than the oceans warming up. And it's hard to believe that the oceans are warming up from anything other than climate change. Okay? This is something that the climate change deniers, I don't know how they rationalize this, but most of them aren't scientists. And you can see where my political alliances lie. Greenland So the two big unknowns are Greenland and Antarctica. If all of the ice on Greenland, which is on land, melts, do you have any idea how far the sea level worldwide will go up? 7 meters. If Greenland melted tomorrow, or the ice slipped off of Greenland, we would have waterfront property here at UCI. If Antarctica melts, we're talking about 55 meters of sea level rise. Now, that's a huge problem, because where is everybody living? On the coast. All of the major metropolitan areas, most of them, are actually coastal. And if you were to think about, and we're not talking about Greenland melting and just the ocean around the United States going up, we're talking about the world's oceans going up 7 meters. And if Antarctica if it melts, it's going to go up 55 meters. This is a huge issue, and to deny climate change is denying your grandchildren of a healthy environment. And I'm hoping maybe that message will get through to some of those idiots. So the last decade, 3.2 millimeters per year were observed, and we see that still this heating of the ocean is the largest contributor there. You can see, though, that Greenland, the increase results from Greenland is about 50% or 100% more than this, and it's just about doubled in Antarctica. How do we figure that out? I'll show you how we do that, and it's really clever the way they do that, and they do it with remote sensing, satellites up there. Glaciers are melting at a rather rapid rate. Almost anybody that's ever seen a glacier, and you see it starting to melt. There's only one, most of the glaciers in Alaska are retreating as a result of less snowfall. There's only one in Alaska. I saw just a thing 2 nights ago about, there's one glacier, and I don't know which one, is still advancing. But the bottom line is that when we're talking about sea level change, we have some quantitative values that show that this is the result of heating of the ocean, melting of Greenland, and melting of Antarctica. Those are the 3 ones that we need to think about. So, if Antarctica melts, I used to teach right down here at Florida International University. This is the Everglades National Park. And if Greenland melts, and then I went up here to Wilmington, North Carolina. That's the Black River right there. And I used to live right on the coast right there. In fact, I could see the ocean from my house. And in fact, I worked at the Center for Marine Science after I was the department chair of chemistry there. And I used to drive my boat to work. Now that's an oceanographer's dream, is to be able to get in your boat and drive your boat to work. But if Greenland melts, we're going to lose all of the Everglades National Park. The Bahamas are going to be just a small fraction of what they are now. But you can see all this lowland here: Georgia, South Carolina, North Carolina, Virginia, up through Maryland, Delaware. This is the Chesapeake Bay. We might even get rid of Washington, D.C. That might be an advantage. And then up in here, we'd probably lose Philadelphia. And here in New York City, well, we already know what happened in New York City a couple of weeks ago. Interestingly enough, I think that probably Superstorm Sandy did more to raise awareness for climate change than any other single thing has happened, because it's hitting us in our billfolds, Wall Street, you know. There's some interesting anecdotes about that, but we won't get into that because we're on television. So if Antarctica melts, now mind you, this is not going to happen overnight. You know, we're talking hundreds of years. But if we believe climate change, it's now that we have to act in order to prevent things in the future happening. We're going to lose all of Florida when Antarctica melts. We're going to lose much of Georgia, South Carolina, North Carolina, Virginia, a lot of Maryland, almost all of Delaware, and the lower part of New Jersey, and most of Long Island Sound is also going to be gone. So now that's going to be a long way. You know, I want to emphasize, you're never going to see that. You're going to see at least, you might see 1 meter of sea level rise by the end of the century if you live that long. Eat your vitamin C and your folic acid and stuff. And if we even get a meter, the Everglades, when I was working at Florida International University, I did a lot of work in the Everglades National Park. The highest point going down from Miami to what we call Flamingo down here, which has got wiped out by a hurricane, so no longer exists, is 1 meter. So most of the southern part of the Everglades is going to be gone. Again, I happen to like ecosystems, so that bothers me a lot. I'm not going to go through these, but there's a lot of people, including some of my friends, that don't believe that the global land-ocean temperature, the temperature's increasing in the world. And if you use this time frame here from, say, 1940 to about 1980 as some sort of a mean, you can see that the global ocean temperature index is moving up. You've got a 5-year running mean, and you've got the annual mean. There's a lot of variability. This exemplifies why climate change is so difficult to wrap your arms around. Because the kinds of changes that we're going to see don't occur on a daily basis. They don't occur on a weekly basis. They only occur on a yearly or decadal or 50-year basis. But when we start to look back at these data sets, it's very clear that something's happening. The question for a long time, was it mankind that was doing this? Was it our burning of fossil fuels that was leading to high concentrations of CO2 that was resulting in increased global temperatures? One of the things that upsets me the most is that places like the Arctic and the Antarctica are seeing 3 and 4 and 5 times the increase in temperature that the rest of the world is experiencing. And in the Arctic, you can see that the Arctic Ocean there's a lot more water in the Arctic Ocean. So people are already talking about not having to go across the entire Atlantic to get from Europe or Russia over here, but actually going through the Arctic, which of course immediately I think of oil spills and stuff like that. So we're going to start to contaminate some of the most precious resources in the world. The northern latitude and the southern latitude are different. The northern latitude, those above the equator, are mostly land, when the southern latitudes, those below the equator, the majority of that is oceans. The ocean has a lot more thermal stability than the land does. The temperature on the land tends to vary like this, and the temperature in the ocean tends to vary like this on an annual cycle. So the differences in the north and the south latitude are primarily different to the amount of land. So this is the northern hemisphere, this is the southern hemisphere, but regardless of where you are in the north or the south, since 1980, you're seeing an increase in temperature. Okay, so this is one thing that we're doing. This is a satellite. So one of the really cool things that's come out of things like NASA and the military, by the way, has been this ability for remote sensing. Satellites Big Brother looking down on you. And there's a satellite called the Gravity Recovery and Climate Experiment, GRACE. It's actually 2 satellites. These satellites are in a position so that they're affected by the magnetic attraction of the Earth. Their altitude is affected by that. They're in constant communication using lasers. They know exactly where each other are within millimeters. Whoops, I hit a wrong button. Okay, back to Grace. So, Jay Famoghetti over in the Center for Hydrologic Modeling, and Isabella Villaconia and her husband Eric Rignot in Earth System Science are using GRACE extensively. Eric and Isabella are looking at the rate at which we're losing mass in Greenland and losing mass in Antarctica. The change in the mass relates to the amount of water that's melting. Before we had these remote sensing capabilities, there was no direct measure of how much water was melting in Antarctica. And probably when the next IPCC, that's the Intergovernmental Panel on Climate Change, comes out, you're going to see that the rate of increase in sea level rise will actually increase dramatically because of our better understanding of the melting of ice on Greenland and on Antarctica. Now let me just step back for a second. The reason I'm focused on Greenland and Antarctica, the only time that ice melting is going to affect ocean level is when it's on land. For example, in the Arctic Sea, the ice is floating on that water. So when it melts, the water doesn't go up at all. And the way you can prove that to yourself is take a glass of water, put some ice cubes in it, measure the level, put a little cap on it so you don't get evaporation, and let that ice melt, and you'll see that the level of the ice in your glass doesn't change at all, because the amount of weight that the ice has displaces the volume of the water. So when you melt the Arctic Ocean, you don't change sea level. You have to have snow or ice on a landmass such as Greenland, such as Antarctica, and such as glaciers, mountaintops, to actually result in an increase in sea level rise. So this GRACE goes over Antarctica, and because Antarctica, the ice depth in in Greenland is about a mile, okay, or it could be up to 2 miles of ice on Greenland. In Antarctica, there's places that have 3 miles of ice sitting on top, and maybe it's 1 and 2, and I'm not sure, but it's a lot of ice. So what happens is with that amount of ice, the gravitational force over Greenland is less than that in an area in the United States or wherever we are here where there's no ice. So what happens is this GRACE satellite goes over Greenland, and there's less magnetic attraction, so it goes up like this, and then it goes down, and then this one goes up and goes down, and there are very, very complex mathematical formulations that you can then determine the amount of mass on these particular land masses, such as Greenland and Antarctica. And if you compare them with time, the assumption is that if the mass on Greenland, i.e. ice, is going down, it's because it's melting. And so at the next go-around, we'll be able to get a much better grip on what's happening. You can see visually using satellites. It is recently as 2002, it appeared that more snow was falling in the higher altitudes of Greenland up in here. But recent studies by Isabel and Eric show that not only is the ice sheet losing mass, the rate of this loss is going up. So not only is it going up like this, not are we losing mass, but it's going up more and more and more. That's that hockey puck phenomenon. So this is looking in 2002. If you look at the ice sheet in over 2003 to 2007, okay, this is the rate of loss in centimeters per year equivalents of ice. Okay, you can see that there's considerable loss here. So this is 5 centimeters per year. No, I'm sorry. We're losing 16 centimeters per year over in here. If you look then at the equivalents up, and we include the data from 2009 instead of just 2007 here, you can see that almost all of the coastal portion of Greenland is losing mass at a rate much, much faster than we predicted. That means that if we go back to that complicated equation that I showed you, is the numbers of increase in millimeters per year as a result of Greenland ice melting is going to go up tremendously. And the same is true with, it's a little bit harder with Antarctica because it's so much bigger. Another thing that Jay's doing over in the Center for Hydrologic Modeling is he's using this GRACE satellite. This Central Valley of California supplies somewhere around 50% of the food in the United States. And what he's now able to do is he's actually able to see that because there's a huge groundwater resource there, which is also in some places very highly contaminated. But it's this groundwater source that fuels the agricultural economy of the Central Valley. And you can see that if we look at over years, you probably can't see this in the back, but this is 2004, this is to 2010, and the trend is that we're losing groundwater in the Central Valley of California. Now, there's also a lot of wells in there, and some people at the Department of Water here in California say, why on earth would you want to do this when we've got all these wells to check it? Again, this looks at a systems approach, and it's a good example of how powerful grace can be. Bottom line, we're losing river water in the Colorado, which also goes into to supply some of the lower part of the Central Valley. In the Sierras up here, because we're warming up, and instead of having a lot of snowpack in the Sierras, precipitation is coming down in the form of rain. And we're losing we don't have a storage capability up here as far as dams are concerned that's large enough to capture that rain, because it was always the bank where you want to save money. Well, hopefully you want to save money in the bank. The bank of snow in the Sierras was always these snow caps up here in the mountains. As climate change, as global warming goes up, that bank is going to be lost. We're going to have less water through the Central Valley. So through a combination of problems, we're going to have less water flowing into the Central Valley from the Sierras. We're going to have less flowing in from the Colorado, which is over here. And if this is one of the breadbaskets of the United States, we're going to be in problems. I'm not going to go over the question of economic models, although I think it's an interest. I think the point here is water, I would argue, is extremely important in public health, if not one of the most important variables in public health. And we're seeing that now, as a result of climate change, and and the other thing, my other pet peeve is economic models, global economic models, not just economic models for Florida or for California. We're seeing that we are having intersections between the environment, energy, food, water, law for sure, and economics. And I think that's going to be where we face the biggest issues. We're going to have to get out of our parochial approach to studying water and go to a more systematic approach. So why? Another thing that I realized is that people undervalue water. So what I did is when I was living down in Aliso Viejo, I went and bought 50 pounds of sand. And I took this sand and I weighed it, and it came out that the sand is about 10 cents a glass. It's not much fun drinking sand. In fact, it doesn't really do anything for your health. Gravel, a clean gravel is about 14 cents a glass. Beach rock, which people use to beautify their lawns, is 37 cents a glass. How much do you think you pay for water, for a glass of water? Now look at this, 0.14, 0.1, 0.4. We pay 0.00023 cents or dollars per glass of water. That is where the biggest problem that we face in the United States. We undervalue one of the 4 essential elements to life, and that is water. Clean water is essential to life. Without water in 5 days, you're dead, or at least severely dehydrated. Actually dead. So,
transcending the current regional conflicts, it is widely believed by a diversity of entities that water can be a bridge to peace in the Middle East and other parts of the world.
And I think that's true. What drives me? It's my daughter and my grandkids. I'm wondering what the world is going to be like when Lily and Ben grow up. Josephine's almost grown up, she's 18. But I wonder, I mean, those things drive me crazy at night. What are we doing? Not you, but what is my generation doing? And you indirectly, where you can vote, about sustainable water for the future. So I think we got just a couple of seconds. Thank you very much.
Thank you very much for the great presentation. I know that it's almost the end of the class.
See, this way I time it this way so you can't ask me any questions.
Well, you are still staying here for.
But I'm still staying here for a couple of minutes.
You have